Hello and welcome back. Root Beer here with more of the 2001 Grade 10 Cayley contest produced by the University of Waterloo. We're up to question number 20, and that's the last question in Part B. Hopefully you've had a chance to take a look. If not, you can go to the University of Waterloo website with the link in the description, the YouTube description, and you can get a copy of this contest as well as many of the other contests. Download them, try them out for yourselves before watching any of my videos, before reading their solutions. It's so much more important that you actually practice. Practice makes perfect. Okay, so without further ado, here's question number 20 on the 2001 Cayley, which again, you can get a copy from the link in the description. Square ABCD with side length 2 is inscribed in a circle. Well, here's ABCD, and it's definitely inscribed in a circle. Using each side of the square as a diameter, semicircular arcs are drawn. And the area of the shaded region outside the circle, but inside the semicircles is... Okay. So, with a lot of these geometric questions, it's always a good idea to get the area of the shaded region you want as a sum or a difference of areas that you are familiar with how to calculate. So a lot of times you'll get a question that is maybe, here's part of a circular arc. We're going to chop out a triangle, figure out what's left, figure out that shaded region. You do it as the difference between that part of the circle minus the area of the square, areas of geometric figures that we know. Okay, so that's what we're going to try and do here. Let's draw a picture. So. Just drawing this, trying to recreate the picture. I'm going to draw my square first, and then draw my circle around it. That's pretty good. And then we have semicircles on the sides of our square. And we want these shaded regions. Well, these shaded regions, let's express them as something we understand. So the shaded region, and this is a fairly typical question on a Waterloo contest, is find the area of a shaded region. So it's the area of the square plus each of these semicircles minus the area that isn't included, which is the area of that whole circle. Okay? And that's going to be... well, if we figure out the area of one of the semicircles, it should be the same, but we'll deal with that in a moment. So now we have the shaded region as the difference between two areas that we can more easily calculate. Okay? So each of these semicircles here, these red semicircles that I'm highlighting, we figured out each of their areas. We'd be doing pretty well. Well, we're told that the square acts as a diameter. So if we could just figure out the side length of the square, we could have it and get the radius. Well, we've got a square with side length 2. Half of 2 is the radius of each of these semicircles, which is 1. And each of these semicircles are going to be the same. So we've got 4 semicircles with radius 1. Okay, so we have 4 times, well, if it's a semicircle, it's half the area of a regular circle. So it's half pi r squared. So that's 4 times a half pi. Well, what's r? It's 1. So the 4 and the half are going to cancel out. We'll be left with 2 pi. So the 4 semicircles have a total area of 2 pi. So this sort of flowery figure is 4 semicircles plus the square. So that's going to be 2 pi plus, well, what's the area of the square? 2 times 2. So this is 2 pi plus 4. Now how about the area of the circle that we will put in orange? So the area of the orange circle, well, if I knew its radius, I'd be all set. We can draw its radius, and it's half of the diagonal of the square. Half the diagonal of the square. Well, the square has side lengths 2, and it's got a right angle here, so we can figure out the diagonal of the square. So it's a half, using the Pythagorean theorem, square root of 2 squared plus 2 squared. So 1/2 square root of 8. Square root of 8 can be written as 2 root 2. So the radius here is going to be root 2. So the area of the circle, well, that's just pi r squared. So that's pi square root of 2 squared, or 2 pi. So the shaded region is 2 pi plus 4 minus 2 pi. Well, the 2 pi's are going to cancel out pretty quickly. And we're going to be left with a final answer of 4. So the area of the shaded regions should be 4. And wouldn't you know, 4 is one of our answers. It's B. So that does it for question number 20, and that wraps up a B part on the Cayley contest rather nicely. So in the next few videos, we're going to be going through part C. Specifically in the next video, we're going to be going through question 21. Part C is the more challenging questions. They're each worth 8, and they should give us quite an adventure to try and get through them. So hopefully you guys will join me for part C. We'll do question 21 in the next video, and hope to see you there.